Hi there, guys. Today we're going to be really looking at this second section in our notes, and we're going to be really dealing with some different probabilities. So let me go ahead and get my pen. So we're going to first talk about theoretical probability. So theoretical probability, and just really any probability, is the measure of how likely something is to occur. That's really another way we can think about it, is how likely is this to actually happen. So the set of all outcomes is the sample space. That's just the term that we use to call this. So for things that are equally likely, so think about like flipping a coin. So you could either flip heads or tails. The PE, now that's our probability, and they're equally likely. And that's going to be, we look at the ratio. And that's a horribly written ratio, but there you go. So we're really looking at the ratio of the number of favorable outcomes. So that's going to be on the top. So favorable is what we really want to happen out of the total, and that's going to be in the denominator. So that's how we're always going to look at these things. So let's look at some simple events. So these simple events mean that one event is happening. So first I have a jar that contains 32 red marbles and 28 blue marbles. What's the probability that a randomly selected marble is red? So looking back up, we're looking at, first of all, our total. So we have to come up with how many total marbles are there. And then we're looking at our favorable outcomes. And in this case, we're looking at red, and we have 32 marbles that would be our favorable, would be red. So to find my total, I would just add both of these together, since that's how many marbles are really in the bag that I have. So I would have 60 total. Well, I don't like leaving my ratios and fractions this way. I want to go ahead and simplify it. So I know that 4 goes into both of these evenly, right? I'm just simplifying my fraction or my ratio. I could divide it by 2 and then divide it by 2 again. That is just fine. So I would end up with 8 out of 15. So this right here would be my probability of that happening. Okay, so let's look at sample number 2, and then I'm going to let you guys work on the rest of those. So for sample number 2, a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So first I always come up with our total. So how many total letters are there? So I got to just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total letters in that word, and then we find our favorable outcomes, which are how many of them are vowels. So 1, 2, 3, 4, 5 of them are vowels. Now that is a fraction or a ratio that I can't simplify, so I just leave it that way. So now I want you guys to work on these last 4 samples, and I will post the answers for you to kind of double check where you're at. So the next thing we're going to look at is the complement of an event. Okay, so we've looked at a simple event, and now we're going to look at the complement of that event. So the complement of an event is the probability that the event is not going to happen. Right, so we looked at the event happening, so the complement would be this event is not going to happen. So since the sum of all probabilities in a sample space, right, so remember that a sample space is all of our possibilities. So the sum is 1, right? That means it is absolutely going to happen. The sum of all those probabilities, and we'll look at some of this, is 1. The probability of an event not happening, and that can be denoted by this little squiggle in front of it. It can also be denoted with a little line over top of the probability. Either one tells us that it's the complement of the event. So this is going to be 1 minus the probability of the event actually happening. So that's one way I can always figure it out. So the probability that it will snow tomorrow is 7 out of 20. What is the probability that it will not snow? Well, I'm going to keep my same denominator, and I'm just going to subtract this 7 from that. So I know that if 7 of those chances are going to be happening, the rest of them, or 13 of those chances, would be it not happening. Okay, so that's how I found the complement. So a month of the year is randomly selected. What is the probability of a month that does not begin with the letter A? So first I would want to come up with the ones that do start with the letter A, just because it's a little bit easier to count. So I know I've got January, February, March, April, May, June, July, August, September, October, November, December. So I know that 2 out of 12 of my months do contain an A. So that would tell me that 10 out of 12, or, right, because I always want to simplify, 5 out of 6, that's the probability that my month does not start with the letter A. So I want you to go ahead and try these last couple of examples, and I'll post the answers for you. So we're going to start looking at compound events. Okay, so compound events are where I have more than one thing happening. These simple events that we've looked at, like just one thing. I pick one marble, or I look at just the snow. So now we're going to be looking at compound events, which is where I have two or more simple events happening. So it could be more than two. Most of the time we'll see two. So first we want to look at the independent events. So independent events are when the outcome of one does not affect the outcome of the other. So that's the probability of A and B right there. Okay, so that's our independent. And we'll look at what an independent one looks like and what an independent and what a dependent looks like. So if the events don't have any impact on each other, I take the probability of the first one happening and I multiply it by the probability of the second one happening. And that's how I can get my final answer right there. So to find my probability, my overall probability when I'm talking about dependent events, and that is where the outcome depends or is changed by the first one happening. So first I take the probability of my first one happening, and then I multiply it by the probability of B after A. So A has to happen, and then I look at that, and then I can multiply it in. So let's look at example number 11. So a die is rolled 3 times. What is the probability of getting ones on each roll? Well, so I've got 3 different events happening, right? Because I'm rolling it 3 times. On each of those events, I have a total of 6 possibilities, but I want one of them. Again, for my second roll, there are 6 possibilities. One of them would be a success. For my third time, there's 6 possibilities, and one would be a success. So these are all independent events, right? Because when I roll a dice, it doesn't have anything to do with what just happened. So then I can go ahead and multiply those together, and I end up with 1 out of 216. So that's the probability of this happening. Okay, so let's look at number 12. So when we're doing this, we have to first figure out, is it dependent or independent? So a coin is tossed, then a day of the week is selected. I would say that those are independent events because they don't actually have anything to do with each other, and that's great. So now let's look at down here. So these are some of our more, another way to determine that this is an independent event. So a bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced. I want to highlight that word. That's a really important piece of information that tells us that it's an independent event. And then another is selected. So we want to figure out what is the probability that I would select a purple one and then a yellow one. So the first thing I have to do is figure out how many total crayons I have. So I add 8 plus 14 plus 6 plus 4, and I end up with 32. So my first grab out of my bag or the box or whatever, so there's 32 possibilities, and I'm looking for purple. So here I have 14 are purple to start with. So then I put that crayon back in my bag. So again, I have 32 possibilities. So then I want to pull out a yellow one. Well, 6 of them are yellow. So now that I have my ratios written out, I can go ahead and multiply these across, and it will eventually simplify, right? I can simplify and multiply. This ends up being 21 out of 256. So there's multiple ways to do that, okay? So think about those ones. So now let's look at dependent events, okay? And here's the key word here. These are not replaced, right? Because that tells me it's dependent, because when I take that first crayon out, I have changed the situation. So that would make it a dependent event. So I want to look down at this one here. Let's actually do 17 first, okay? So I want to look at yellow and then red. And I'm going to scroll up just a little bit so we can see what we're talking about. So on my first grab into the bag, there's 32 crayons, and I'm looking to get a yellow one, and there are 6 yellow ones. Well, we're going to pretend that I got that yellow one, and it's out of the bag now. So when I reach in the second time, there's only 31 possibilities now, and I want to be able to get a red one. And there are 8 red ones. So that would be what I would eventually multiply there for that one. Okay, so now let's look at these 2 reds. That's going to change things a little bit, okay? So my probability of 2 reds. So the first time that I grab into the bag, there's 32 possibilities, and 8 of them are red. Well, the second time I grab in, there's only 31 possibilities, and we're going to assume on that first grab that I got a red one. So there's only 7 red ones left that I could grab. So then again, I go ahead and I multiply and I get my final answer. And I'll go ahead and give you those final answers right here. So this one would be 3 out of 62. This one ends up being 7 out of 124. So I want you to look at numbers 18 and 20, try and think about them. So I want you to think about how we can do this with decks of cards too, because we'll see that a lot as well in these dependent events or independent events. Okay, and that's really it for our notes on this section. So really the biggest thing I want you to be aware of is how can I determine, is my event dependent or independent, and what do I do differently when I'm finding that overall probability? Because that's what you're going to be doing in your homework. So as always, just let me know when you get stuck or have questions on anything. Thanks, guys.